Have you ever wondered how a train can climb a mountain? It seems impossible, doesn't it? These incredible feats of engineering are called mountain railways. They are lifelines, connecting remote communities, showing us breathtaking landscapes. They are also masterclasses in problem solving. This video will take you on a journey through two very different but equally fascinating railway worlds. We will compare the soaring lines of Switzerland with the rugged tracks of Scotland. Two countries, two climates, two brilliant approaches to civil engineering. By the end, you will understand the core challenges and clever solutions that make these railways possible. Swiss mountain railways are world famous for their audacity. They climb slopes so steep that a normal train would simply slide backwards. The secret often lies in a special piece of equipment called a rack and pinion system. Imagine a third rail running between the main two, but this one has teeth like a giant zipper. A cogwheel underneath the train, the pinion, engages with this toothed rack. This gives the train an incredible amount of grip, allowing it to haul itself up gradients that would otherwise be impossible. Another defining feature of Swiss engineering is the extensive use of tunnels. When a mountain is too steep or too unstable to go around, the Swiss simply go through it. Tunnels provide a direct, shorter route, but their most important job is protection. They shield the line from the constant threat of heavy snow. They shield the line from devastating avalanches. Some of these tunnels are incredible feats, burrowing for miles. The Jungfrau Railway runs inside the Eiger and Mönch, with windows carved into the rock face. Magnificent bridges and viaducts cross plunging valleys, masterpieces of structural engineering, built on solid rock to withstand immense weight and harsh alpine weather. Swiss engineers are also pioneers in electrification. Most of their mountain lines are electric. This provides the smooth, powerful traction for steep ascents and the controlled braking for safe descents. Electric power is reliable in the cold and cleaner for the pristine mountain environment. Building and maintaining these lines is a monumental challenge. Early crews drilled and blasted with rudimentary equipment. Today, the focus is on maintenance and safety. Engineers use advanced sensors to monitor rock stability and predict avalanches. They have built huge steel and concrete galleries, like sheds over the track, to let snow slide harmlessly overhead. Drainage systems channel away meltwater, preventing freeze damage to foundations. It is a constant, high-tech battle against the forces of nature. Well, that's Swiss precision for you. The mountain railways of Scotland tell a different story. Here, the challenge is less about extreme altitude and more about rugged terrain and relentless weather. The Scottish Highlands are characterized by vast, boggy moors, deep valleys known as glens, long, winding sea locks. To navigate this landscape, many original builders chose a narrow-gauge track, allowing much tighter curves. The railway could snake around hills and follow the contours, avoiding costly blasting. Unlike the Swiss, Scottish engineers built fewer long tunnels. Their lines hug the landscape. The West Highland line winds around the shores of Loch Lomond and crosses the wild, empty expanse of Rannoch Moor. The moor is a giant peat bog. Engineers floated the track on turf and brushwood, a solution that has held up for over a century. Bridges are robust and beautiful, local stone and mass concrete. The curving Glenfinnan viaduct is a perfect example. The biggest enemy is not snow, but water, erosion and landslides. Maintenance is relentless. Keep ditches clear, inspect culverts, and fight salt corrosion and frost heave. When we place the Swiss and Scottish approaches side by side, the differences in engineering philosophy become crystal clear. The Swiss confront the landscape, rack and pinion to go straight up, and long tunnels straight through. High cost, high-spec infrastructure for ultra-reliable, all-weather operation. Scotland works with the land, narrow gauge, winding alignments, minimal earthworks, and local materials. The primary battle is water and soft ground. Drainage and foundation design lead the way. Firstly, slope stability is paramount. Nets, walls, and soil management prevent landslips. Secondly, drainage is non-negotiable. Get water away from the track or risk undermining the entire structure. Finally, rigorous maintenance. Snow clearance and avalanche checks in Switzerland. Storm patrols in Scotland. Inspect track, sleepers, and ballast. The only way to guarantee safety in such environments, you know. Swiss lines teach rack railways, long-span viaducts, and extensive tunnelling, what ambition and budget can achieve. Scottish lines teach clever alignments, use of local materials, and water-first design in wet, rugged terrain. Don't forget to like, share, and subscribe ET Muster.